All right. So now we're going to look at a circle a little differently. So I have a circle graphed here for you. And it has a point for the center. And that point is occurring at 1, 2, -2, 1, 2, 3, 3. So first I want to ask you is what quadrant is that? Where is the center of my circle? Is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? Do we remember our quadrants? Maybe, possibly. Well, let's remember. This one to the top right is quadrant 1, where all your positives are. The one below it is quadrant 4, where you have positive x's and negative y's. To the left is quadrant 3, negatives everywhere, x's and y's. So that would mean this is quadrant 2, where your x's are negative, but your y's are positive. So in case you didn't remember that, jot that down. Now, I want to identify 4 lines that are tangent to the circle. Now, there are endless amount of lines that are tangent to the circle. Remember, a tangent is a line that rushes right up against the side of your circle, doesn't actually break in. You can do this all the way around the circle. In multiple places I can go. Again, this is going to be tangent. I can go again. I know how to identify some easy ones that, can jump out and not be difficult to find. So a big hint here is about vertical lines. How do you create lines that are perpendicular? Because we need right angles. At the top of your circle, you can have a line that is horizontal and brushed over the top. Perpendicular to your radius. And the equation of that line, it's horizontal, so that means it's y equals, and we are at 3, 4, 5, 6. One line down. We could copy that on the bottom, go horizontal across the bottom, getting a little crooked. And that's also going to be perpendicular to the radius, and that is y equals 0. So that's 2 lines. So those are our horizontals. What about our verticals? Can we slide down the side? Let's see. There we go. And that looks like it's going to be perpendicular to the radius. And that's, if it's a vertical line, the equation is x equals a number. So let's find out where that is. That line hits right at x equals 1. I'm not looking for the line that is going to the radius. I'm looking for the line that we drew alongside the circle, not the one that's breaking into the circle. Keep that in mind. And then the last one, I can go on the other side, do the same exact thing. So counting over, that's at x equals -5. And yeah, that's going to be perpendicular to that radius as well. So like I said, there's countless ones we could find, but thinking about your horizontal and vertical lines, creating a box around your circle is the fastest way to find tangents for your circle. Let's try another example of that. So scroll over to the top here. For example 10. So first I'm going to identify, I have a center that lies in the first quadrant. I don't know where it is. We have no idea where that center is. So we are going to have to locate it and then write an equation for it. They do give me some tips. The first one says that one of the lines that's tangent is x equals 8. So I'm just going to draw a big line down where x is equal to 8. So I find x is equal to 8. And I'm just going to take this whole line with me. Now that means if it's tangent, our circle is going to either have to lie directly against it over here or directly against it over here. It's going to actually touch that line. So these are adding boundaries for the line. Next, I'm going to do equals -3 or +3. +3 is a line right here. There we go. So if it says the center is either going to be over here, or it's going to be really, really tiny and be down here. Because if it drops down too low, the center will no longer be in that quadrant. So we get one more piece of information, and it says x is equal to 14. So that's this guy right over here. So if our circle is tangent to all of these, can it go in this space and still touch the purple line at x equals 14? No, it cannot. So it's either going to have to go on top of the green line or below the green line. So we need to figure out what's the distance between the orange line at x is 8 and x is 14. That's going to give us the diameter of our circle. And once we have the diameter, we can figure out our radius. And that'll help us to figure out which side our circle is going to be on. Okay, so I'm going to count across 1, 2, 3, 4, 5, 6. So our diameter is 6. That means our radius is equal to 3. So if our radius is equal to 3, now we need to figure out, are we on the top part or are we in the bottom part? So we're going to count out for our radius. I don't believe it's in the bottom, so I'm going to check that one first. First, I'm going to count over 1, 2, 3. That's going to be the middle where my center point will be for x's, and then I'm going to count down 3. 1, 2, 3. So if it's on this point at 0, 11, is it actually in the first quadrant? No, it is on an axis. So that is not going to work for the situation. So it is not going to be down here in the bottom. It is in fact going to be on top. So I counted over 1, 2, 3. Then I count up 3. 1, 2, 3. So right here is where my center point is. I don't need these anymore. Oh no. There we go. That is my center point. And now I'm going to create a circle that's going to touch those 3 tangent lines. And it's going to have a diameter of 6. Oops. So I'm going to be fancy and sketch around like this. My circle drawing skills are not the greatest. So yes, I am using the benefit of technology right now. Go up a little bit. I think that's a little large. Yeah, that needs to be shrunk down just a tad. And that looks better. There we go. So now my circle fits in the space. It's touching all 3 sides that it is tangent to. If you wanted to be like, oh, what's the 4th tangent line? That would be the line that's going across the top here at y equals 9, if you would really like to, but you don't have to. Now let's write the equation. Our center is at 11, 6. So that's my HK. So now I can write my equation that says x minus 11 squared plus y minus 6 squared equals radius squared, which will be 9. So it sounded really scary at first, but it as long as you graph out your tangent lines and find your diameter, it's not too shabby.